You may be wondering, how do we randomly shuffle boxes around here? Well, at a high level, there's something called the Durstenfeld, which is also called the Fisher-Yates shuffle. Basically, some people just came up with this idea, got it named after them. Very cool, whatever. It's actually pretty simple. You start at the very last element in the array, the very last number that's in there, and you randomly choose any position earlier in the array before that. So if I have 100 boxes, I pick the 100th box, and I pick a random number between 1 and 100. And I go and grab that and just swap them. Now, I repeat the process. I move to the second to last element. Pick any random number between 1 and 99 now, up to, where I'm actually looking at right now, my second to last element. So let's say I pick box 3 and 99, swap them. Move to 98, pick a random number between 1 and 98, swap them, and so forth. You just keep going down until you get to the last element, which is going to be a very boring swap because you're going to say, well, pick a random number between 1 and 1 and swap box 1 with box 1. So, you can stop at box 2 if you want to, but that's the idea behind this this kind of shuffling. Now, people had to prove that actually works, that gives you an equal probability of intermixing the boxes, that there's no bias there. There's not like a greater chance that, number 99 will show up in position 3 more often than position 4 or something like that. So this is called uniform distribution. You don't have to know anything about that kind of stuff, but the idea is we want to have an even chance of every number to show up in every box. And this does do that. So yay, we're going to use that technique. Again, just going from the back of the array to the front of the array, randomly swapping. So we just need to pick lots of random numbers between 1 and 100, 1 and 99, 1 and 98, and so forth, all the way down to 1 and 2. So that means we're going to first need a generic random number function. Now, if you remember right from last time, we saw a pick a random number between 1 and 3 function. So we're going to now generalize that by first reviewing that function to pick a number between 1 and 3, and then kind of extend it so that we can do it between 1 and anything. So let's create our random number function now. I'm going to go right here under create boxes and just say function random num. And I'm just going to have this one do the hard-coded, pick a random number between 1 and 3. Now, if you remember right, math.random, I'm going to return math.random here. Math.random gives you a random number between 0 and almost 1, like 0.9999999 is totally fine, but it will never actually return 1. So be it. And if I come down here and just, let's console.log this too. Console.log random num, and yeah, random num is my function name. So I'm just going to say random num just directly like that. So notice there's 2 closing parentheses there, brackets. Random num is just calling this function up here that returns math.random, and we're just going to console.log that. So let's see what that does. Yep, 0.33 something, 0.89, and notice it's still printing my array because I have the console.log here. I can remove that or I can comment that out if you want to, just for the moment, just because I don't need to see it. So now you can see, whoops, there we go. So you can see this is just generating lots of random numbers between 0 and 1. Yay, just like last time. So remember, if I wanted to get this to a random number between 1 and 3, I needed to multiply it by 3. Because the range is 0 to 1, if I multiply by 3, it's 0 to almost 3. It's 0 to almost 1 to 0 to almost 3. So let me do that. Times 3. And remember to asterisk, the shift 8 is times. So let's click run on that. Notice I'm getting numbers now between, you can see this 2.689, 0.83, still gets some stuff in 0.9 range, 2.11. I should get a 1 point something at some point. There it is, 1.46. So anything 0, 1, or 2, almost up to 3, but not quite. Now, I wanted something that was 1, 2, or 3, not some random decimal 0, 1, or 2. So there's 2 things I need to do. if you recall correctly, we have a math.floor. So I need to round down. I need to just chop the decimal point off. And that's exactly what math.floor does. So let me clear this again. I'm going to click run, and notice now I'm getting 1, 2, 2, 0, 1, like I'm just getting numbers 0, 1, and 2. Because, again, remember, when I multiplied by 3, I got 0, 1, 2, almost up to 3, but not quite 3. So when I chop decimals off, I'm just getting 0s, 1s, or 2s. And it's just ignoring the rest of the decimal. So 0 through 2 isn't quite what I wanted. The last thing I have to do is add 1, right? Plus 1 gives me, instead of 0, 1, or 2, it gives me 1, 2, or 3. And that's finally what I asked for, or what I was aiming for anyway. So notice now I'm just getting 1s, 2s, and 3s. Perfect. So this is just the weird way that you have to do random numbers in JavaScript. You take this function that gives you just random numbers between 0 and 1, you scale it, and then you shift it a bit to get it into the right range. So that gives us a little bit of an idea how we're going to have to modify this function now if we wanted it to generate a random number between, say, 1 and 100, or even, say, 3 and 100. So that's what we're going to do next. So, case in point, if I wanted to instead generate random numbers between, let's say, 5, starting at 5, and do 5, 6, or 7. So we're still going to do 3 numbers, but we're going to do 5, 6, and 7. All I do is change this to a 5, right? It was going to do 0, 1, or 2, but now I add 5 to it, and that's 5, 6, or 7. And if I clear this, you'll indeed see 5, 6s, and 7s show up. So that tells me that whatever number I want to start at, that's what I need to add right here. So, good. I can do that. If I want a random number between A and B, I can, say plus A here, right? I haven't handled the B part yet, and I'm going to come down here and just say I want a random number between 1 and 5 to start with, let's say. So we're going to fix this in a second so that it actually respects my inputs here. The number 1 is being used, but not the number 5 yet down here. So you'll notice that this doesn't actually do what I want it to yet. If I click this, notice I'm getting numbers 1, 2, and 3, but never any 4s or 5s. So what is it that could give me 5 instead of 3? The answer is the scale, right? If I need 5 possible numbers, I need to multiply by 5 instead of 3. So I'm going to multiply by b here. This isn't quite going to be exact yet. It's going to work for this case, but we're going to talk about one more case where it doesn't work for, but we're getting closer. At least by multiplying by b, I'm getting more numbers. Now, if I say I want a random number between 1 and 5, I'm going to multiply by 5 and then add 1 to do the shift at the end. And that is going to be right in this case. So let me clear this. Now notice I'm getting 5s, I'm getting 4s, I'm getting 2s, I'm getting 1s. So all I've said so far is random number starting from A to B. I passed in A equals 1 down here and B equals 5. And that meant that I took a random number between 0 and 1, multiplied by 5. So now I have 0 up to almost 5. Chop the decimal place, so I only have 0, 1, 2, 3, or 4. And then I shifted it by 1, because that's what A is. So instead of 0 to 4, I have 1 to 5. Now, why is this not quite right? This doesn't, unfortunately, work if I change the numbers to anything besides a starting point at 1. So if I do 2 to 6, let's see what happens. So I clear this and I click run. And notice I'm getting 7 sometimes. I'm getting 3s. So what happened here? Why didn't that work? Well, some people might have noticed, but just in case, remember I said the scaling factor is how many numbers you want. So if I was going to do like we did when we did a random number between 5 and 7, notice 5, 6, and 7, that's 3 numbers. And remember just a few minutes ago, we had multiplied by 3 to get that. Not 7, not the second number B like we said here. But rather, how many numbers are between A and B, including the endpoints A and B. So 3 was how many numbers are between 5 and 7. That's what we have to fix here. When I say how many I want a random number between 2 and 6, I don't actually want 6 different numbers. I only want 5. 2, 3, 4, 5, 6. 5 total numbers. So it's close and tempting to say, you know what? Instead of multiplying by b, let's multiply by b minus a. Now, if that isn't intuitive, that's okay. Don't worry about it. I'm going to put in my second parenthesis there, or bracket. Why I'm doing that is how many numbers are between 5 and 7. Well, I should subtract them to figure that out, right? But notice it's off by 1. That's why I said there's a small glitch here. So I want 3 random numbers because it's 5, 6, and 7. But if I do 7 minus 5, it's only 2. The reason why is because what you've said is 7 minus 5 says how many times do I have to move to get from 7 to 5? And the answer is twice. But if you want to include 7 as the endpoint, you actually need to add an extra 1 at the end. So that's exactly what I'm going to do. Plus 1. So this works. Let's try it with another example. Random numbers 2 to 6. That's 5 different numbers. 2, 3, 4, 5, 6. 6 minus 2 is 4. 1 under 5. So we add 1 and get back to 5. This is how we scale our 0 to 1 to have 5 different numbers when we say A is 2 and B is 6. And then we shift the whole thing by 2. So instead of 0, 1, 2, 3, 4, we get 2, 3, 4, 5, 6. And that's our function. Annoying math. Hopefully that made some sense. Try a couple more examples if you want, because I think it becomes clear that really this is telling you how many random numbers do I want between A and B, including both endpoints of A and B. That's what this B minus A plus 1 gives you. And then once you shift that scale that and then do the floor, you're always going to have 0, 1, 2 up to, if you wanted 5 numbers, you're going to have 0 through 4. If you wanted 10 numbers, you're going to have 0 through 9. It's always going to be 1 under. And then you're just shifting the whole thing by A, your starting position, to get it into the right place. That's all this is doing, this plus A at the end here. So with that, we can test it out. I can click run here, and notice I'm getting random numbers 2, 3, 4. I haven't seen a 3 yet. There's a 3. 2, 3, 4, 5, 6. I'm seeing all those numbers, and I'm not seeing anything else. So this is actually working as intended. Now, we're obviously going to use this not in the main run function, but we're going to use this in a shuffle array function that we're about to write. But at least now we can generate random numbers between any 2 numbers. 1 to 100, 1 to 99. We could do 5 to 7 if we wanted to. Again, if I change this to 5 and 7, notice just like last time, except now that we have written our full function, we're doing it for real. I'll clear this again. We're generating 5s, 6s, and 7s. So yay, we can generate random numbers. So now let's work on our shuffle function. So I'm going to come up here and make a function called shuffle array. And it's going to take the array here. And this is something that is worth mentioning. When you pass in an array in JavaScript and you make modifications to it inside the function, that is visible outside the function. This is not always the case with inputs, but it is true with arrays. So that's just something to know for right now. This is pass by value versus pass by reference for those who are familiar with those terms. Pass by value just copies the value. So you can make a modification all you want inside the function and it will do nothing. Pass by reference is I'm giving you the thing itself that I am going to take back from you at the end effectively. So any changes you make to it will be visible to outside the function to the caller. Arrays pass by reference. That's just how they work. That's for memory efficiency because it'd be really annoying to copy an entire list of numbers. Very inefficient. So people would stop using functions with arrays if they were always copying them. So, okay, how are we going to shuffle our array? Well, actually, let me first call that down here. I'm going to delete my console logs. And then in create random boxes, I actually do want to call shuffle array, right? So I go up here. I'm going to call shuffle array boxes. Doesn't do anything yet except call an empty function. But the idea is if shuffle array moved things around, now boxes is very random and now we return it. Oh, I actually didn't mean to delete my first console.log that I had commented out. Console.log boxes. I'm going to want to see what is actually happening to boxes as I shuffle them about. Okay, so let's just run this and make sure I know what's going on. So notice again, I got my 100 boxes again, all the way 1 to 100. Nothing's shuffled yet. No big surprise there. Now, remember what we wanted to do. We wanted to start at the end of the array, pick a random number, swap, move to the second last element, pick a random number, swap, keep going. The random number range is always shrinking to the last, including the last element. You could actually swap the number with itself at like any position if you wanted to. So we do need a random number between 1 and 98 when we're looking at position 98. So sometimes the swap may do nothing. That's okay. All right. So how do I go do 100 things in that kind of order? Well, I need to start at the length of the array, right? At the end of the array and move backwards. So that's going to be a slightly different kind of for loop than we're used to seeing, but it very much the same for loop. It's just going to look, we're just going to be doing slightly different things in the same kind of for loop. So let's write that down. For let I equals, well, I want the length of the array. I'm just going to write length of array right now, which is going to be complete gibberish. So that JavaScript has no idea what I'm talking about here. And while I'm actually still above the first element. Now, here's where we get into some sadness. In JavaScript, arrays start counting at 0 in terms of position. What that means is the first element is in the 0th position. The second element is in the position 1. The third element is in position 2, and so forth. It's sad, but it's, again, historical legacy reasons for memory accesses and things like that. We just have to get used to that. When looking at a specific position in an array, it's always going to be one less than you think because it starts counting at 0 instead of 1. So what I really want to say is while the position is greater than or equal to 0, while I am still inside the array, keep going. Now, remember what I said about we can actually stop at the second element, right? Because if you get to the final element, you're just going to swap it with itself and there's no point. So I can actually say I greater than or equal to 1 here, which means keep going up through the second position in the array. Weird, right? But position 1 is the second number in the array. That's the last time we're going to do a swap. We're going to pick a random number between 1 and 2. And we're going to swap. Possibly it's going to pick the same element, like position, 1, which is the second element. It's going to swap it with itself, and then it's going to end. That's fine. Or maybe they'll swap it with the 0th element. So, which is the first element to us humans. Okay, so that's what the I greater than or equal to 1 means. And now I'm going to do I minus minus. That's right. There is the opposite of plus plus. We had talked about it a little before, I think. But the idea is this is the same as I equals I minus 1. Yay. So this is how you, what they call decrement instead of increment. This is how you reduce a number by 1. So we're going to start counting at the length of the array, roughly, and then we're just going to keep going down by 1 until we reach 1. We'll do things a final time, and then when I is 0, we'll stop. That's what this array is going to, this for loop is going to do. So let's put our curly braces in here. That'll hopefully make these errors stop happening. Well, maybe not. Oh, right, because the length of array. All right. The cool thing is JavaScript does give us array.length. This is actually a thing. That actually does exist, and that will be the number 100. So, good to know. That is how you get the length of an array. You just say, you just give it the name of the array. In this case, my variable is called array. I could call this ARR or something short and then do ARR.length. that'd be fine. I'll do that just so that we don't think there's anything fancy about the word array that I'm using here. Yeah, and then we have to remember, oh no, positions are always one less than we think. So if an array has length 100, that means the positions of it are 0, 1, 2, all the way up to 99, not including 100. Because remember, 0 to 99, that's 100 things, right? Because 1 to 99 would be 99 of them. 0 is 100 of them total. So we can't actually start at array.length. We have to start at array.length minus 1. So, yay. What's this doing? It starts with I equal to, if array.length is 100, it starts with I at 99, which is the position of the last element in our 100 array of boxes. We keep minusing, going backwards down the array from the last element all the way down to position 1, which we will run the loop for. Position 1 is the second element. And then we stop. That's what this array, or that's what this for loop does. So what I'm going to do is I'm just going to console.log in here. I and array square brackets I. This is how you actually grab the ith position inside the array. So I'll call this array too so it's clear what's going on. Let's see what this does. Woohoo! Okay, so notice it printed my boxes like it usually does, but notice all this crazy stuff it just printed here. That's a lot of stuff. Notice what it was doing. It says position 99. Notice array at position, like this is our I variable is the position in the array. And notice it grabs inside the array, go to position 99, and get me whatever number is in there. In that case, it's the number 100. Remember, because our boxes are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever, all the way to 100. If we grab the last element, it's going to be 100. Then the next to last one is going to be 99. Next one, 98. Next one, 97, etc. So notice it is just grabbing every element in the array and printing them out backwards because it's going backwards down the list. Notice again, we get to I equals 1, which grabs whatever is in the 1 position inside the array because this is the 0 position. This is the 1 position, and it grabs the number 2, and then it stops. Notice it never goes down to the very first element. Okay, weird. I don't like it maybe, but fine. So what do we want to do each time in the loop? We want to swap 2 numbers. We want to randomly pick a number between, one in the current position we're at, which again is actually going to be 0, and the 0 in the position that we're at because we are having to count with 1 less. Yeah, basically, I feel like I'm going to try this one more time to make sure I get it right. We want to swap position I with anything between 0 and position I. That's what we want to do. Because that says swap anything from the first element of the array all the way up to the top. There we go. Sorry about that. Okay, so let's do this. Let j equal random num 0 to I. That'll get me a random number between 0 and I. Now it's good that we didn't, we defined it configurable between A and B. A can be 0. That'll actually work. And now how do we do a swap? Well, it's actually not too bad. Whoops, sorry. We could just say, let some temporary variable be array at position I, right? We want to swap whatever's at position I and whatever's at position J. So array, sorry, there we go. ARR is what I'm calling my array right now. Array I, and then let's let array J equal, array I equal array J. And then let's assign array J equal to temp. This is a 3-way swap. This is very much the same way that you might actually swap two real things in real life. If anyone remembers the movie Indiana Jones, where he's taking like the statue off the thing in the Raiders of the Lost Ark and he's putting the sand thing on it. Notice what he really did there was he has two things. He needs to swap them. And so he's going to take one into a third position, move the sandbag into the first position, and then, take the statue and put it back where the sandbag used to be in his jacket or something like that. So that's kind of what's going on here. We're just saying, you know what, take whatever's in position I and shove it in this temporary space. Now I can actually shove something in that position that I just copied basically here. So I say, okay, take array J and shove it into array I. Notice that now array at position I and array at position J have the same number. If there was a 5 at position J, there is now a 5 at position I. That's why we had to save the value of array I so that we didn't lose it, right? Because now array I got overwritten. So now we say, okay, take, if temp had, if array I had before had the number 12 in it, then temp has 12. Now we have two 5s in both positions, but now we say, okay, take array J and shove the 12 in it. So now if array I was 5 before and if array I was 12 and array J was 5, 12 goes in here, 5 goes into array I, and then 12 goes into array J. And so we've effectively swapped the two positions. Swapped the numbers in the two positions. Now, that's the normal way of doing it. There's a way to have the computer do that little swap for you in just one line. So I wanted to show this just because this is a very classic way to do it. But some languages, and JavaScript is one of them, allows you to do array I, comma, array J, and to do this in square brackets itself equals, and again some more square brackets, array J, comma, array I. So believe it or not, this does the exact same thing as the other thing. Notice this says, okay, I have basically a list of two things, and these are backwards from these. This has I first, then J, that has J first, then I. So it actually magically kind of grabs all the values from J and I, and then shoves that in I and J, which does the swap for you. It's basically making the temporary value for you behind the scenes, and so you don't have to worry about it. So, believe it or not, this is the shuffle. I'm going to get rid of this. All we've done is picked a random number between 0 up to the position we're at right now, which is constantly going down. We swapped the two elements in this one line, or in the 3 lines if you prefer. And then we just go down, move the position to the next biggest, or not next biggest, but the next biggest position. So from 100 to 99, 99 to 98, and so forth. We're moving it one down each time. And just keep going. Just keep swapping. So let's see this run. Ooh, look at that. That looks kind of random. Let's press it a few more times and see what happens. Okay. Yeah, notice that. It is just sitting here and swapping numbers like crazy 100 times for each of these, possibly. And notice it is quite random. I mean, looks random enough to me. I wouldn't really know, but I don't see any reason to, compare two of these. Like the number 53 is here. I don't even know where it is in this list down here. Oh, there it is, I think. Yep, 53 is right there. And, it's in other places in other lists. This looks random enough. So cool. That's it. We've got the hard part. We've got our boxes completely random, and we actually could start the game now. And real quick before that, I'm going to clean up by clearing this out, closing the console, and coming down here. We don't need to log this anymore. We have the beginning of our game. So now we can say we are going to create that number of boxes. Boxes equals that, and we can actually play with those boxes in the future. So next time, we're going to do the actual game with those boxes that we've created.